Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects, titled Differential Evolution-based Routing Protocol for Optimizing Communication in MANETs. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the applications that we have designed in the domain of the wireless network communication by using the optimization algorithm. This is related to the mobile networks, mobile ad hoc networks. So let's move to the video. Before moving to the video, let's talk about that what we will cover into it. In this particular video, we will initially talk about the application areas, then we will talk about the code, how to execute, which file you need to run, what are the software requirements and the library requirements for it. Then we will talk about what were the current systems, those who are working in the same domain and the problems identified on them, and finally what we have proposed in the method and developed in the video. Then final experimental outcomes and findings will be analyzed. So let's talk about the application area. As I already told, that system is designed for the mobile ad hoc networks, which is under the wireless communication, so it is not restricted to any single domain. So for any industrial communication, for the smart agriculture, smart buildings, intelligent transportation, for the biomedical domains, for the EVs vehicles, where the communication among the vehicles is to be done, which is also known as MANETs or ad hoc networks, right? So other than that, in the domain of the computers, for the Wi-Fi, Bluetooth, aerospace communication, GPS, the wireless communication technology is everywhere. So the design protocol is basically a routing protocol which is forming a route from one point to another by using the certain parameters. So now let's have to look to the code. So in order to run the code, you will get this folder under which all the files for the code have been placed. You just need to copy the path, and then you must have the MATLAB software installed on your system. The MATLAB version that I'm using is R2019, so you can use 2015 or the above version. So currently I'm demonstrating in R2019A. Make sure it should be a full version, not the trial one. So to run the code, go to the folder where the whole code is placed, just copy the path and then go to the MATLAB and just paste it here, press enter. Now you have the different files in it, so out of which you just need to run the main mobility vary, main node vary, and main node vary delay, right? So these are the three files, and finally a comparison has been done under the file name that is R analysis, right? So to run the code, you just need to click one of the file and then click on the run button. So it will start executing the code. It will show you the factors, how much mobility you need to use, because we have run for the different scenario. Let's say I'm entering it here 5, so I will press enter. Let me see if I know. Yeah, so press enter. You can see it will take the mobility as input, and on that behalf it will process the information. Now it will ask which node you want to get as a transmitter. Let's say I'm choosing 22 as a transmitter and 25 as a receiver. 22 and 25. Press enter. You can see it will process by using the optimization algorithm and will give you the route from that particular node to the destination node. So if particular neighbor is not found within the range, as you can see, this node is far away from other nodes and not effective node, so it is giving you this error dialog box. So I'm running it again. Mobility is again 5. This time let's see which node can be transmitter, which can be receiver. 8, 19. So 8, 19. Press enter. So overhead we got is this, and PTR value is this, delay is this. Now running the other scenario. So before moving to that, let's talk about that what exactly the work was. We have chosen this paper as a base paper under which they have implemented the technique of the fuzzy logics with the multi-constraint in order to form the root. So they were considering the few parameters. Those parameters were delay, bandwidth, and energy only. So one of the problem that we have identified is all these three parameters are not enough. Other than that, there are certain other factors. Those are important in deciding the node to be the next hop. Secondly, if the parameters are going to be increased, obviously the fuzzy will not be effective enough to handle that load, so we need to replace it. So what we have done, we have replaced it with the differential evolutionary optimization algorithm, which is selecting the best route on the parameters that we have decided. The parameters that we are using for evaluating, we are adding two more factors. Those factors are, let me show you. Those factors are basically the distance, the energy, the average distance within the range, and the throughput. So 5 of the factor we are using. So when I'm running the code, you can see in the same paper they have run the whole scenario for the different scenario where they are varying the mobility. In the second of scenario, they are changing the number of nodes. In third of the scenario, they are changing the delay factor. So by using those factors, we have created three codes in which, yes, you can see initially the area, nodes, and the locations are given. They are plotted. The energy model is implemented because energy is there. Random movement point is used for the mobility. Mobility is generated. And then drop rate, energy, and throughput we are generating randomly, and on that behalf we are calculating the distances of all node with respect to another, and on that behalf energy consumption is also calculated. Then we are making a table for all the information in the network. Then source and destination node is taken, and finally while the source becomes the destination, it means when the next hop is the destination one, until that the loop will be run, and the it will find the best node. So that node will be selected by the differential evolutionary algorithm under which the fitness is evaluated. Cost function that we have kept is weightage given to 1 by distance plus delay plus weightage into energy into bandwidth. So parameter is being increased. So on that we have whatever the best node will be selected, that will be added to the root, and final root has been placed, and the results has been analyzed in terms of different factors that I've already shown, that PDR, delay, and overheads. In the second scenario, we are just changing the node number as per the base paper. So we are getting the input from the user and getting the nodes. And thirdly, we are changing the delay factor. So you can see the number of nodes are varying, as well as we are getting the delay factor variation among the outcome. So finally, when all these three codes has been run, you can see at the end we have saved the results for all the three scenarios. And for doing the analysis part and comparison with the base paper, we take the results directly and compare them by defining them here. You can see, so when I run this file, it will get the results of the proposed one and show in the tabular as well as in the graphical form. So the graphical results are basically, let me show you. This is the control overheads by the change in the mobility of the tradition and the proposed method. Here, the proposed method is the DE based MMRP. Similarly, this is the individual hours result only. This is packet delivery ratio of packet delivery delay of hours. This is the comparison. So you can see our delay is less. Similarly, this is the delay. It is less with respect to mobility. Similarly, this is the packet delivery ratio with respect to mobility. So in our case, it is higher, nearer to 100. So this is the graph of our packet delivery ratio. Finally, this is by changing the number of nodes for the PDR. So in all the scenarios, the proposed system is effectively showing the results, and you can also see the results down there in the tabular form. So further modifications are still possible into it. For that, you can contact us directly and can get the information. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.